This is a video demonstration of a prototype I created as part of my design process for a new eye imaging device for Zeiss Meditech. This simulated system was created using Acture and was used for sales demonstrations, user testing, communicating the system function and look and feel to developers, and by the quality assurance team for system validation. Let me explain a few parts of the system. We have a left to right columnar workflow, as you might expect. Here, the user selects the scan and the field of view to be used. Down here, we have a workflow panel. This shows the laterality, scan type, and field of view that I've selected up top. And were I to go through a full exam, different scan types would show up as additional rows, so I have a readily accessible record of what was captured. For this demonstration, I'm going to capture a series of fluorescein angiography images instead of true color. So I'm going to change my scan type to FA, which we can see is reflected in my workflow, and I'm also going to change to the wide field setting to start with. This information is also reflected over here on the right side of the screen in the bin where the thumbnails of the images will show up as they are captured. This is the information known prior to image capture. After each image is captured, these metadata will also include a timestamp that is important to the interpretation of FA images. The next step is to align the camera to the eye. I designed an illustrated representation of the eye in the alignment space with guides to show the optimal positioning of the camera relative to the eye. Alignment is managed by moving the camera using a joystick and rotary control. I had to simulate the hardware action, so created this control panel to represent movement of the camera along the X, Y, and Z axes. So as the user, my goal is to move the camera so that the eye lines up with the axis guides. You can see here, I got within the acceptable range on the y-axis, so it turned green. Now I do the same thing for the x-axis, so both indicators are green. But I'm not close enough to the eye, so I'm going to move the camera forward until the z-axis guide turns green, and when all three axes are green, the eye illustration also turns green, letting me know that I'm fully aligned and ready to capture my image. This is my live view. This represents the eye of the patient seated at the device. And this little green thing, I'm going to make it blink for a bit. This is the fixation point indicator showing where the patient should be focusing their gaze. If you click on the main viewport, the fixation point will move to the preset closest to where you clicked. You can also drag it for more customized positioning. Now, because this is an image type that requires a timestamp, these timers appeared when I selected FA. The timers are not visible when other untimed scan types are selected. So I'm going to start the timer, then I'm going to come down here to capture the first image. And we can see over here is the thumbnail of the image I just captured. For other image types, after the image is captured, it would show up in the main window for 3 seconds before the window reverts to the live image. This serves as a quick quality check to let the doctor know if he or she needs to recapture that image. However, for fluorescein angiography, because so many images need to be acquired in quick succession and the flow of the dye makes the recapture impossible, the quality check is disabled. But at any point during the process, I can click on any thumbnail and that image will show up in the main view until I toggle it off by clicking on the same thumbnail again. But my timer is running, so I'd better capture some images. After acquiring a couple more wide field images, I want to switch to an ultra-wide field view. The ultra-wide field capture requires stitching together of 2 images with preset fixation points, so the prototype automatically moves the fixation to the correct location with each subsequent capture. As you can see, the images that are populating the bin are accurate in terms of fixation and timestamp, which was crucial in avoiding the distractions that can be caused by inaccurate placeholder images and system behaviors during demonstrations with end users.